Wind shear over England, March 1943. A P-47 Thunderbolt prototype dived through cloud at 420 miles per hour. Air temperature, minus 12 degrees Celsius. Altimeter, 10,200 feet. The pilot leveled out, but the wings shuddered under recoil as 6 Browning .50 caliber guns tore into the air. Tracer streaks bent upward, slightly left. At that velocity, deviation measured fractions of a degree. Enough to miss a target at 300 yards. Enough to mean failure. The vibration amplified through the frame. The guns stopped. One jammed, the other misfired. The aircraft rolled 5 degrees. Momentary imbalance corrected only by brute force on the control column. Data sheets later recorded lateral torsion 0.21 inch at the outboard spar. Oscillation frequency 41 cycles per second. Within the test tower at Republic Aviation, engineers noted structural resonance beyond predicted harmonic range. No one yet understood why. In a drafting office overlooking the test runway, Margaret E. Davis wrote the numbers again. She did not erase. She recalculated. Her pencil moved in short, measured lines, each stroke parallel, deliberate, precise. The page contained only figures: recoil momentum, torsional stress, vibration amplitude. No commentary, only physics. Republic Aviation Corporation, Farmingdale, Long Island, 1942. Factory complex spread across 70 acres, 14,000 workers. Inside the main hangar, machinery roared from dawn until midnight. Hydraulic riveters echoed against concrete walls. The smell of cutting oil and exhaust filled the air. Sheets of duralumin hung in stacks, each tagged with alloy batch number and tensile rating. Assembly bays ran in linear formation: fuselage, wing, tail, armament. At night, under floodlights, the plant resembled a metallic river, parts moving on conveyor trolleys toward completion. The war demanded speed. The Air Corps needed a fighter to survive dives past 500 miles per hour. German Focke-Wulfs dominated at altitude. The United States required power, range, strength, stability. The XP-47B prototype promised all three. Engine? Pratt & Whitney R2800, 2,000 horsepower. Weight? More than 8 tons fully loaded. Armament? 6.50 caliber Browning machine guns. The design was unprecedented. Massive, heavy, overbuilt. A flying engine encased in armor. Margaret Davis joined Republic in late 1941, months before Pearl Harbor, age 29. Background: aeronautical engineering and ballistics analysis. Trained under Civilian Pilot Training Service, later reassigned to mechanical systems design. Her handwriting resembled blueprint lines, exact spacing, no deviation. She occupied desk 12A in the Ballistics Division, 3rd floor, West Wing. Title: Assistant Armament Engineer. Responsibilities: synchronization of firing mechanisms, recoil distribution, and gun mount harmonics. Her specialty was invisible. Recoil sequence, vibration timing, resonance isolation. Each firing pulse traveled through mounts, into spars, across skin. At high velocity, even a microsecond delay altered trajectory. She studied those intervals like pulse rhythms. Her notes referred to them as harmonic interferences, not recoil. To her, firepower was mathematics. The early Thunderbolt design carried 6 guns, 3 per wing. Each gun fired at approximately 850 rounds per minute. Combined, more than 5,000 projectiles left the aircraft every 60 seconds. At firing, recoil force equaled 600 pounds per gun, distributed unevenly,
That force twisted the wings. In dives above 400 miles per hour, the vibration converged with engine torque and aerodynamic flutter. The result? Dispersion, stress, fatigue. Not visible, but measurable. Davis observed test films frame by frame. Each muzzle flash corresponded to a small deflection in wingtip position. Sequence analysis showed asymmetry between right and left wings, fractional yet consistent. 3 guns could not maintain harmonic balance. She concluded the imbalance would vanish only through symmetric distribution of recoil impulses. An even number. 8 guns, not 6. Her report ran 5 pages. Title: Preliminary Analysis of Firing Resonance XP-47B. Proposal: add 2 Browning M2s per wing. Outer mount staggered 6 inches aft to counter yaw. Additional weight: 260 pounds. Rate of fire: 6,800 rounds per minute. Compensatory measure: install staggered firing solenoids. Delay 0.012 seconds between adjacent guns to equalize momentum waves. Mathematical basis: resonance cancellation through phase displacement. She presented the data to Section Chief L. E. Dawson, Armament Engineering. His annotation in margin: weight increase unacceptable under current performance targets. The file archived, unresolved.
But Davis persisted. She refined calculations, replaced theoretical mass with exact gun weight, 61.5 pounds each. Total increase: less than 1.2% of gross load. Negligible. She reissued her memorandum with empirical data. Test requisition followed. 1 prototype modified to 8-gun configuration. Winter 1942 to 43. Republic Aviation Test Range, Mitchell Field, New York. Ground crews rolled the aircraft from Hangar Bay 4. Serial 41-6065. Engine start at 9:42 hours. Outside temperature -4 degrees Celsius. Barometric pressure 30.01 inches. Pilot Lieutenant Harold Lane assigned to test. Objective: firing pattern and structural response. The first run commenced at 5,000 feet. Air density high, temperature stable. Guns fired in staggered sequence. No torque deviation. No yaw. Flight control normal. Data from strain gauges recorded vibration amplitude 0.08 inch, half the value of previous model. Wing deflection symmetrical. Test considered successful. Second run conducted at 12,000 feet, 440 miles per hour. Continuous fire 10 seconds. Ammunition expended 900 rounds per gun. Barograph recorded mild oscillation. No resonance beyond 0.05 grams. Pilot note: stable, controllable, smooth. At 15,000 feet, all 8 guns fired simultaneously. The aircraft held true. Tracers formed a perfect line through cloud. Photographic evidence confirmed grouping within 2 meters at 300-yard distance. Precision unprecedented. Davis reviewed the recordings that night. On the oscillograph trace, she marked the point where firing harmonics canceled. 2 pulses met, amplitude 0. Her equation verified in air. She signed the chart with date and code, SPEC 47, a gun mount mod. Within weeks, the 8-gun configuration adopted for production. The War Department approved modification under Armament Specification Number 91-47F. The change increased total firepower by 33%. But its true achievement lay in stability. The Thunderbolt could now dive past 500 miles per hour
without structural failure or gun dispersion. Production expanded. Republic Aviation's assembly lines operated 24 hours a day. Floodlights illuminated the factory roof. Steam rose from exhaust stacks over the frozen Long Island fields. Each day produced 12 completed airframes. By mid-1943, deliveries exceeded expectations. All carried 8 Browning M2s. All bore the invisible logic of her calculation. Davis's workspace overlooked the final inspection bay. From her window, she saw wings mounted to fuselages under sodium light. She recorded gun mount torque readings: 480 pounds at recoil, 5.7 g acceleration through the mount strut, tolerance within design limits. She logged results, initialed EMD, and stored them under File Folder Sedan A. Each notation identical: clean, mechanical, final. Combat reports soon reached Farmingdale. Pilots described the Thunderbolt as indestructible. Dive speed 550 miles per hour. Operational ceiling 42,000 feet. Climb rate 2,900 feet per minute. Firepower unmatched. A single 2-second burst delivered more metal than an entire Spitfire sortie. At full deflection, 8 guns expelled 48 rounds per heartbeat. German pilots called it Der Fleischwolf, the meat grinder. American crews shortened it to the Jug. In June 1943, the 56th Fighter Group deployed to Europe. Their mission: escort B-17s over France and Germany. Operational losses fell as Thunderbolts entered service. Each formation carried hundreds of guns, synchronized through her timing circuit. Machine vibration turned to precision. Fire became geometry. Within Republic's Ballistics Division, production continued under controlled secrecy. Documents marked confidential, Ordnance Branch only. Her name appeared in no public file. She remained at her desk, adjusting harmonic tables for sustained fire sequences. Each variable, temperature, altitude, ammunition weight, entered manually. No emotion, only outcome. Wright Field, Dayton, Ohio, July 1943. Armament Test Report 2112B evaluated firing accuracy at 400 miles per hour. The P-47's 8-gun spread measured 18.4 feet at 300 yards. Comp-reported 6-gun aircraft spread 26.3 feet. Result: improvement 30%. Failure rate 0.7 per 1,000 rounds. All data confirmed the stability of staggered solenoid timing. The report ended with the phrase, "No further correction required." Underneath, a hand-stamped code, EMD, her initials. She never saw combat. Her world was noise, graphite, metal. Her decisions lived inside machinery. Each figure she wrote became action, multiplied thousands of times over Europe. By late 1943, the P-47 dominated the western skies. Production exceeded 5,000 units. Pilots learned to dive vertically from 25,000 feet, firing bursts through cloud cover. Structural integrity remained perfect. No wing separation. No harmonic failure. The aircraft could outdive any pursuit.
Records show that by December 1943, 78% of aerial kills credited to Thunderbolts occurred during dive or strafing engagements. Her design had turned mass into control. Recoil became stability. Force became equilibrium. Inside Republic's engineering department, memos multiplied. Install new recoil dampers per specification 47A. Align firing solenoids phase differential 0.012 seconds. every instruction derived from her equation. None bore her name. She remained a statistic among thousands of civilian engineers, categorized under temporary wartime technical personnel. But the machinery of her mind persisted in flight, invisible and exact. In the winter of 1944, she supervised vibration analysis for the P-47D model. Altitude simulation chamber tested firing at pressure equivalent to 30,000 feet. Temperature -45 degrees Celsius. Electrical solenoids exposed to cold cycle stress. All units passed. Her recalibration extended firing reliability by 11%. The Thunderbolt continued to evolve. Razorback canopy replaced, wings strengthened, range extended. But its essential geometry remained unchanged. 8 guns, staggered fire, balanced recoil. The logic she had written in 1942 carried forward through every variant. Field reports from the European theatre grew increasingly precise. Fuel capacity 370 gallons, range 800 miles, average mission 4.6 hours, ammunition expenditure 4,300 rounds per sortie, probability of gun jam less than 1%. Each metric stemmed from her calculations. The war advanced, and the aircraft bore its reputation. By 1944, the Thunderbolt became a machine of endurance. Pilots trusted it implicitly. They survived because mathematics had corrected chaos. And somewhere, in a quiet office on Long Island, an engineer verified the numbers again. Altitude, velocity, recoil, no error, no deviation, only precision. The data traveled farther than she ever did. By spring 1944, the European air war reached maximum intensity. Allied bombers crossed the continent daily. P-47 Thunderbolts flew ahead and beside them, their 8 guns synchronized, stable, predictable. Dive bombing and escort missions extended deep into Germany. Altitude 27,000 feet. Temperature -48 degrees Celsius. Fuel pressure 22 pounds per square inch. Engine manifold 44 inches of mercury. The pilots felt the aircraft respond instantly under fire. Recoil absorbed by geometry they could not see. Their confidence in the machine became absolute. Mission logs show the pattern. Frankfurt, Hamburg, Cologne, Regensburg. Each sortie followed the same formula. Roll in from altitude. Dive angle 50 degrees. Airspeed exceeding 480 miles per hour. Burst length 3 seconds. 8 guns releasing a uniform pulse of metal into rail yards, fuel depots, and airfields. The plane held true, never veering. Each impact the product of a calculation performed 2 years earlier, at a desk covered in blueprints. Republic aviation engineers received data from field maintenance crews through coded teletype. Every combat unit logged gun jam incidents, ammunition feed issues, recoil deformation, and vibration anomalies. The reports showed an unmistakable trend. The P-47's 8-gun mount recorded fewer failures than any other American fighter. Mean time between malfunctions exceeded 50,000 rounds. By contrast, the P-51 Mustang's 6-gun layout suffered recurrent feed tension problems under high acceleration. The difference was mechanical balance. In April 1944, Davis analyzed feedback from the 78th Fighter Group, Duxford Airfield, Cambridgeshire. Pilots reported 0 torsional resonance during high-speed dives.
Vibration data transmitted from accelerometers matched her original harmonic model, within 0.7%. The structure behaved as predicted, no correction necessary. She noted it on the log sheet. Confirm stability, specific 47A, unchanged. Then she closed the file. Republic Aviation reached its production peak that year. The Farmingdale complex operated under constant noise. Cranes moved wings, engines, fuselages along narrow tracks. The smell of hydraulic fluid mixed with metallic dust. Compressors vibrated through the floor. At night, workers in coveralls welded under yellow light, sparks marking the air. Every 52 minutes, a new Thunderbolt rolled off the line, each one identical, each one containing her hidden equation. Across the Atlantic, pilots used that design as a shield. The P-47 absorbed punishment that destroyed lighter aircraft. Armor thickness 56 millimeters forward, 20 around cockpit. Heel tanks self-sealing, resistant to incendiary fire. Its massive engine acted as armor plate. Even when hit, the fighter remained controllable. Many pilots returned with holes large enough to see daylight through the wings. They called the plane the Jug, short for Juggernaut, for its shape and for its refusal to die.
Combat performance statistics confirm the legend. From mid-1943 through 1945, Thunderbolt squadrons destroyed 4,200 enemy aircraft in air combat and 9,000 on the ground. Average sortie success rate 97%. Loss rate below 0.5 per mission. Each figure born from the same foundation, an aircraft that fired straight under stress. Her formula governed that precision. She had treated recoil not as violence but as vibration. Her logic converted destructive force into symmetrical motion. Every bullet fired in pairs, momentum canceled by momentum, movement replaced by equilibrium. Mathematics transformed chaos into order. The Army Air Forces adopted her gun mount layout across all Thunderbolt models. P-47C, D, G, N, all 8 guns. Serial production exceeded 15,000 units. Each carried the specification tag, Armament 8x.50 caliber Browning AN/M2. Total ammunition capacity, 3,400 rounds. Firing rate 100 rounds per second combined. Every manual traced back to the code SPEC 47A gun mount mod. No further revision required. The war expanded toward its end. By 1945, the skies over Europe belonged to the Allies. The Thunderbolt led the way into Germany, escorting bombers over the Rhine, the Ruhr, Berlin. Each flight another demonstration of her calculation at work. Pilots fired 8 guns simultaneously, maintaining linear accuracy even while pulling 6G in recovery. Maintenance crews logged 0 gun mount failures and 31 consecutive missions. Her equations endured where armor and engines were replaced. Republic's ballistics division shifted to post-combat analysis. They received damaged wings, gun mounts, and spars shipped back from European depots. Engineers measured stress deformation, inspected rivet lines, recorded warpage. Davis compared recovered parts with her predicted load curves. Deformation never exceeded forecast values. Her calculations remained valid under real combat stress. She documented every result on Form R47 Test 9. The file now contained proof, empirical and complete. The war ended without ceremony inside her office. May 8, 1945, VE Day. At 1100 hours, production halted for a moment. Sirens sounded. Then machines resumed. Orders continued for post-war contracts, experimental variants, training aircraft. No one in her department spoke about the celebration outside. They kept working. By summer, the Thunderbolt line began to slow. Fewer shipments. Excess material inventory stored in sealed crates. Blueprints reclassified from confidential to obsolete. Yet Davis remained, cataloging harmonic data for Ordnance Division archives. Her position redefined as civilian consultant. Her payslip listed only hours, not history. In August, when Japan surrendered, the factory turned silent again. Engines cooled, the air filled with the smell of dust instead of fuel. She filed the last vibration chart and shut her drafting lamp. On its metal base lay the faint residue of graphite and oil, evidence of thousands of hours condensed to a thin gray film. Post-war assessments confirmed what combat had already shown. The P-47 Thunderbolt became the most durable single-seat fighter of the war. Engine survivability 85% after direct flak impact. Wing failure rate below 1 per 1,000 sorties. Firing dispersion reduced by 30% compared with early prototypes. The modification listed simply, recoil balance, Spection 47A. The report's appendix carried her data unchanged from 1942. Her arithmetic had survived the war without amendment. In 1946, Republic Aviation transitioned to peacetime production. Davis remained through contract closeout. Then her name disappeared from personnel lists. Employment file closed under notation, temporary consultant, completed service. No record of transfer or further employment. Only her work persisted in machinery still flying overseas. The Thunderbolt continued in service under new flags. French, Brazilian, and Mexican air forces flew the same aircraft through the 1950s. Korean War records noted its ruggedness under new conditions. Maintenance bulletins still referenced her firing synchronization diagram. The code 47A gun mount mod remained printed on parts catalogs. Her design had outlived the war. As the jet era began, engineers studying vibration dynamics returned to her data. Early jet fighters experienced recoil imbalance from autocannon mounts. The same resonance principles applied. Technical papers from 1951 cite staggered solenoid synchronization as a method first implemented on the P-47 platform. That method traced directly to her specification. Her influence extended silently into the future, embedded in every weapon that required harmony between fire and flight.
Years later, historians at the Air Force Armament Laboratory reviewed archival ordnance drawings. Among them, one sheet labeled Gun Mount Modification 47A, margin note, phase delay circuit 0.012 seconds verified. Under the title block, M. E. Davis, NGR. No further information, no biography, only numbers. Time reduced her contribution to an initial and a formula, yet the machines she shaped continued to exist. Thunderbolts preserved in museums, each with 8 gun ports aligned symmetrically along the wing. Visitors looked at armor and paint, not mathematics. The balance inside those wings remained unseen, silent, exact. At Republic's former factory site, concrete foundations cracked under weeds. The hangars dismantled, equipment sold, blueprints stored. In one archival box, a yellowed envelope contained her test report, 5 pages. Graph paper, graphite lines, typewritten labels. Equation describing recoil harmonic amplitude over time. The shape of stability plotted in ink. No diary, no photograph accompanied it. Only the curve of vibration settling toward zero.
That curve defined everything she achieved. Technical archivists scanned the documents for digital preservation. The data transferred into modern units, milliseconds, newtons, degrees. Even degrees. Even after conversion, her values aligned perfectly with contemporary models. Recoil load differential 0.7%, at phase delay 0.012 second. Mathematics independent of era. The physics of her thought remained true. One modern researcher annotated the digital file. Design basis of recoil harmonization systems, early example. That was all. Her signature remained in small faded letters at the bottom corner. The last operational P-47 flew in South America in the late 1960s. It carried the same armament configuration she had designed. No revision ever replaced it. No engineer improved the balance she found. After 3 decades, her equation still functioned flawlessly. Today, the aircraft survives in museums, polished for display. Inside each wing, 8 gun mounts rest in silence. The solenoids still aligned in pairs, each separated by the fraction of a second she calculated. Visitors see symmetry, not purpose. But the silence itself is her legacy, the absence of vibration, the calm born of balance. She never flew a mission. She never left the factory floor. Her field was vibration, not sky. She studied movement until it ceased to exist. Every time a P-47 fired its 8 guns in perfect sequence, her equation came to life. Every flight proved her precision. When the war ended, her name receded into paper. Specification sheets filed in drawers, reports stamped archive. But machines remember patterns even when people do not. The harmonics she solved became part of engineering language. Every modern weapon system still traces back to her logic. Counterbalance recoil through phased energy release. Her numbers live inside blueprints, diagrams, software. Invisible, permanent. The factory that once shook with engines now stands silent. Wind moves through empty hangars. Dust settles on floor plates where Thunderbolts once waited for paint. The echo of machinery has faded into memory. Yet somewhere within that silence remains her pattern, 8 points of balance, frozen into metal. No ceremony marked her departure, no medal, no obituary. Only the continuation of an equation written before dawn in 1942. It endures through every test report, every flight log, every surviving airframe. Firepower became mathematics, mathematics became survival, and survival became her unspoken monument. The blueprint corner bore her initials, faded now, yet every P-47 that followed carried her correction in silence.